Okay, now let's look at some relations we have here. Now if you've understood HCF and LCM, these should be fairly straightforward. The first one is that the HCF of x and y will be less than equal to x when x is less than y. So in simple terms, if I am trying to find out the HCF of two numbers a and b, the HCF will be smaller than the smaller number of these two, the smallest number, or equal to. So the HCF will be less than a equal to a, or an HCF will also be less than equal to b. It will be smaller than the smallest number or equal to the smallest number. Now the corollary for LCM is simple. LCM will obviously be greater than both the numbers because it is a multiple of these two numbers. So the LCM is greater than equal to a if a is greater than b. So this is what I have. So if I am trying to find out, let us say the LCM of 2 and 6, it will be greater or equal to 6. In this case, LCM of 2 and 6 is 6 itself. Now it says if the HCF of numbers n1, n2 and n3 is h, then n1, n2, n3 can be written as multiples of h. So this is very important. You might be using it in many questions. So let us say let me just take two numbers first. The HCF of x and y is equal to h, which means that x is divisible by h and also y is divisible by h. Now let us say when I divide x by h, I get a number a. This I can write because h completely divides x, there is no remainder. Similarly, y divided by h is equal to b. Now cross multiplying, I can simply get x is equal to ha and y is equal to hb. So this is a representation of x and y when the HCF is h. In this case, one thing you need to know is that a and b are co-primes. Why are a and b co-primes? Because had they not been co-primes, then this means that there is a bigger factor than h which would divide both x and y. So after dividing by h, I should not be left with any common factor, otherwise that would have gone into h itself. So x can be written as ha and y can be written as hb. This is the representation that this rule is talking about. Now this is again very important. If the HCF of two numbers n1 and n2 is h, then the numbers n1 plus n2 and n1 minus n2 are also divisible by h. So actually they follow right from this itself. So I am saying here that HCF of x and y is h. So x can be written as ha and y can be written as hb. So now if I take the sum of these two numbers, what will that be? It will simply be h times a plus b. So as you can see, the sum of these two numbers is also divisible by h. Similarly, if I have x minus y, that is going to be h into a minus b. Again, this number is also divisible by h. So all I am saying is if my HCF of x and y is equal to h, then x plus y and x minus y are both divisible by h. Now this is again something which you will be using in questions later. You will be seeing how I will be using this to find the answers more quickly. Now the next rule says if L is the LCM of some numbers, in this case n1, n2, n3, n4, then all the multiples of L are divisible by these numbers. So let us say that I have L is equal to the LCM of A and B. So all it's saying is that L is divisible by A because L is a multiple of A. Similarly, L is divisible by B because L is a multiple of B. That is why it is the least common multiple. Now if I take multiples of L, that is L into 2 or L into 5 or L into any number m, obviously if L is divisible by A, then this number is also going to be divisible by A. Similarly, this number is going to be divisible by A. Similarly, this number is going to be divisible by A, because like in fractions you can just cancel these out. Similarly, this is also going to be divisible by B because L is divisible by B, and this is divisible by B and this is divisible by B. So all the multiples of L will be divisible by both these numbers or all these numbers. In this case, this is a generalized formula where we have let's say more than 2 numbers, n1, n2, n3 and n4. So all multiples of L, that is L into any number, is going to be divisible by all these 4 numbers here. This is all it's trying to say.